Good morning, everyone, and thank you for joining this session. Today, we are going to talk about how artificial intelligence and satellite data are changing the way we understand crop prices. Traditionally, what happens is crop prices are often influenced by the market rumors, delayed field reports, trader assumptions, and seasonal uncertainties. But today, with the help of satellite imagery, weather information, crop monitoring, and AI based analysis, it is possible to predict a crop price much earlier and much more accurately. This topic is becoming extremely important because agriculture is no longer only about production, it is equally about planning, forecasting, and making the right decisions at the right time. In this session, we will understand how crop price prediction works, what role AI and satellite data plays in it, and how these technologies can benefit farmers, industries, and governments. So, what is commodity price? A commodity price is basically the market value of an agriculture product such as wheat, rice, sugarcane, onion, cotton, soybean, or maize. These prices keep changing depending on multiple factors like crop prediction, weather demand, supply, market arrivals, then export, import, also storage. Commodity prices are important because they directly affect the income of farmers. If prices suddenly fall after harvest, farmers may face huge losses, even if production was good. On the other hand, if we see, if prices rise unexpectedly, consumers and the industries may struggle due to higher cost. For example, every year we see a sudden spike in onion, tomato, sugar, or pulses. Sometimes the crop production is high, but prices crash because too much produce reaches the market at the same time. So, understanding and predicting prices becomes very important for someone in the agriculture value chain. You can think of a crop price like the heartbeat of an agriculture. When prices are stable, the whole ecosystem works smoothly. When prices fluctuate widely, everyone feels the shockwave. Now let us see or understand why price prediction is necessary. Price prediction helps farmers decide which crop to sow, when to sell, and whether to store the produce for a better price that is coming later on. For traders and industries, it may help in planning the procurement and the inventory. For government, it helps in managing the food security, buffer stocks, imports, exports, and farmer support programs. Without prediction, people only react after the prices have already changed. But with prediction, we can act in advance. For example, if we know that the soybean prices may fall after harvest because production is expected to be very high this year, then farmers can explore storage options or they can also diversify their crop. Similarly, in a sugar mill, the sugarcane production will be lower due to drought conditions, and the sugar factory then can plan the procurement much earlier. So, price prediction converts uncertainty into preparedness. Instead of waiting for the storm, it is like it gives us an umbrella before the clouds even appear. There are many benefits of crop price prediction. First, farmers can make better decisions about sowing as well as selling. Second, traders can avoid uncertainty losses due to sudden price fluctuations. Third, food processing industries can plan their raw material procurement in advance. Fourth, financial institutions and insurance companies can better estimate the risks. And finally, consumers can benefit because stable prices reduce sudden inflation in food commodities. So, better prediction leads to better planning, and better planning leads to fewer surprises in the market. Now, we look at what the government benefits. So, government crop price prediction is extremely useful because government can use these predictions to identify possible shortage or surpluses in advance. If there is likely to be a shortage, they can plan imports early. If there is a surplus, they can plan exports, storage, or procurement through MSP schemes. Price prediction can also help government take timely action to control inflation as well. For example, if onion prices are expected to rise this time, government can release buffer stocks or reduce the export activity. It can also help in the policy making, then subsidy planning, then there is crop advisories, and even in disaster responses. So, in many ways, we can say that predictive intelligence acts like a agricultural weather forecast for all the policymakers. Okay, now before AI and satellite technology became common, price prediction was mostly done through traditional methods. Now these will include the historical price trends, manual survey, mandi reports, trader experiences, then there is farmer feedback, and also the seasonal assumptions that we make. For example, if last year onion prices increased during a particular month, people assume the same pattern might repeat. Similarly, if a farmer in a region reported lower sowing, then traders expected price to increase. These methods were useful, sure, but in only some extent. But when they are often show, they are subjective and also very incomplete in nature. So the biggest limitation that we have seen of a traditional method, that is they depend heavily on manual reporting, like we saw. So sometimes field reports are coming in late, sometimes data is also incomplete, sometimes the assumptions are wrong because weather conditions can change unexpectedly. Traditional methods also struggle for large area coverage. Now imagine trying to estimate crop production for an entire state only through manual field visits. It is definitely very time consuming, it is expensive, and often very inaccurate. This is where technology enters the picture like a satellite image of a maze. Suddenly, you can see the whole landscape instead from guessing of the ground. Now, AI and satellite data have come into the picture and have changed the entire game. Satellite can continuously monitor crop fields across huge regions. They can provide information about crop area, the vegetation health, any water stress, soil moisture, weather impacts, and crop growth stages as well. AI then can process all this information along with the market data, historical price, rainfall, there is demand and also supply. Now, by combining all these different data sets, AI can identify patterns that humans often miss. For example, if rainfall is below normal and satellite data shows poor crop growth, AI can estimate that production may be lower and prices may rise this time. This is not just a prediction, it is like giving agriculture a crystal ball powered by pixels, weather map, and machine learning. So, satellite data will provide several important insights. See, it helps estimate the crop acreage. It shows crop health using vegetation indices like NDVI. It tracks the drought, flood, pest impact, and even the moisture stress. It can even identify change in the crop growth over time. Now, AI will help in processing these huge data sets quickly. It can compare the current conditions with the past years. Then it can identify trends, detect what anomalies are there, and generate a prediction based on all this. Now, that's why together AI and satellite data create a much stronger decision making system. Now, let's look at the key components of price prediction. There are 5 major components. First is the crop area estimation. Second is a yield prediction. Third will be the production estimation. Fourth is the market arrival. And fifth is the demand analysis. Now, all these factors will come together to influence a final market price. You can imagine price prediction like cooking a complex dish. Or one ingredient is alone, it is not enough. The final taste depends on all the ingredients when they all come together. So If we look at crop area estimation, what is that? So crop area estimation basically means identifying how much land is being used for a particular crop. Satellite images can help determine how many hectares are under soybean, wheat, sugarcane, cotton, or even rice cultivation. If crop area increases significantly, there is a chance that the production may also increase. And if production increases too much, prices may fall. Similarly, if crop area decreases due to drought or low farmer interest, then the prices may rise. So, area estimation is one of the early signs or the signals in price forecasting. Then comes yield prediction. So, yield prediction means estimating how much crop will be produced per unit area. So, AI uses satellite imagery, then rainfall data, temperature, soil moisture, and crop growth patterns to estimate a yield. For example, the healthy green vegetation in satellite imagery usually indicates the better yield. Poor vegetation or water stress may indicate lower yield. Now, yield prediction is important because even if crop area is large, poor yield can still reduce the total production. Similarly, a small area with high productivity can still produce enough good supply. Production estimation. What that does is production estimation combines crop area and yield. When both area and yield are known, like we saw before, total production can be estimated from this. This is one of the strongest indicators of future prices. If production is expected to be high, prices may decline. If production is expected to be low, prices may again rise. This formula may look simple, but it drives the massive decisions in agriculture market. Market arrivals will mean how much produce is reaching mandis or our markets. Even if production is high, price depends on when and how much produce enters the market. If huge quantities arrive at the same time, prices may crash. If supply is released gradually, prices may remain stable. Controlled supply over support stable prices. So low supply can lead to high prices. This is why storage, cold chains, and transportation also influence prices some way or the other. Sometimes the market behaves like a straight line, more like a traffic jam. Too many trucks arrive together and prices get stuck in that chaos. Now we'll look at the demand analysis. Demand is another major factor that will play a role. Demand can be domestic demand, it can be the export demand, it can be the industrial or the seasonal demand. For example, sugar demand increases during festive season. Then there is cotton demand that depends on the textile industry. Oilseed demands depend on edible oil consumption. Demand can be also affected by the income levels or the consumer preferences, festivals, weather, and even the export policies if they change. Now, AI can analyze historical demand patterns and predict the future demand changes. This makes the prediction model more accurate. Now let's look at the price prediction model. Once all the information that we have discussed so far is collected and fed into a price prediction model, the model makes multiple inputs such as the crop area, yield, production, then there is rainfall, there is also temperature, market arrivals, the historical prices, and the demands. The AI techniques such as machine learning or time series forecasting, any kind of neural networking can be used. Then the model will give us an estimated price range for the future weeks or even months. Now the output may not be always exactly perfect, but even 80 to 90% accurate forecasts can have a huge and a greater value in agriculture planning. Let us now take a look at all the methodology that goes into it. So first, satellite images are collected. Second, what happens is the crop area and the crop health as well are analyzed. Third, there is weather and soil data that has been added. Fourth, it happens is that historical prices and demand data are collected. Then what happens is AI models will process all these data sets. Finally, price predictions are generated by them. So the process moves from raw data to useful decision. This is why today's presentation is also subtitled from data to decision in agriculture. Now we are looking like for a real world example or a use case. Now let us look at a real world use case of sugarcane, for example. Sugarcane is very important crop because it affects sugar production, ethanol production, and the livelihoods of millions of farmers. Satellite data can help estimate the sugarcane area and monitor the crop health as well. AI can estimate like production based on rainfall, irrigation, and the vegetation pattern that it shows. If production is expected that this time it is low, sugar prices are automatically going to rise. If production is expected to be high this time, sugar mills can prepare for the larger procurement. Now what this will do, it will help the farmers, industries, and government also to make the better decisions much earlier before time. Now, if let's summarize what the benefits we have seen so far. So for farmers, what are the benefits of satellite and AI approach? It's that it means that the better planning and better prices. For industries, it means smoother procurement and supply chain management for them. For government, it means a stronger food security and better policy decisions or changes. For researchers and agri-tech companies, it opens a new possibility for precision agriculture and predictive analytics. So instead of operating in darkness, the sector gets a dashboard with headlights. For farmers, we are looking for especially, and AI and satellite-based predictions can help answer very practical questions. For example, which crop should I grow? When should I sell? Should I store or produce or sell the produce immediately? Will the prices improve next month? Or they can also get these small questions get a very definitive answer after this. Now let's look at what the industries will benefit. For industries such as sugar mills, then there are food processors, then there are exporters, even textile companies, oil companies. Price prediction is equally valuable because it helps them to forecast the raw material availability. It helps them manage their inventory. It helps them reduce the procurement risks. And it helps them to maintain a stable operation when the market conditions can change suddenly. And lastly, for the government, we are looking. So predictive agriculture can support food securities. Then there is inflation control, procurement planning, and even disaster responses. Government can also use these technologies for crop insurance, subsidy targeting, and farmer welfare schemes. So all this will create a more resilient agriculture system together. So to conclude, agriculture is moving from traditional guesswork to data-driven intelligence. AI and satellite are helping us predict crop production, market arrivals, demand, and prices much more accurately and better from before. This technology can reduce uncertainty, improve the profitability, and support smarter decisions across the whole agriculture ecosystem. So in the future, crop price prediction will become even more powerful with real-time satellite monitoring, IoT devices, drones, and even advanced AI models. The future farmer may not just look at sky from the rain, they may also look at a dashboard for price signals. Thank you everyone for today's time.